Hello and welcome to our practical investigation on measuring density. In our previous lessons, we've explored the arrangement of particles in solids, liquids, and gases. We learned that in solids, particles are tightly packed in a fixed arrangement. In liquids, they are close but can move past one another, and in gases, they are far apart and move freely. We also discussed the concept of density, understood as the amount of mass per unit volume. And we've seen the density equation, which is density equals mass divided by volume. Before we get started, let's briefly outline the importance of this practical. Firstly, density is a key property that helps in identifying various materials and verifying their purity. For instance, in metallurgy, professionals use density measurements to distinguish between different metal alloys and detect impurities or defects. Quality control in food production also relies on density to maintain consistent product quality, like ensuring the density and texture of a dairy product. Secondly, the principles behind buoyancy also hinge on the concept of density. Engineers and architects frequently use density measurements to design structures and systems that must interact with fluids such as ships, submarines, and even hot air balloons. Thus, by measuring density, we not only deepen our theoretical understanding of the concept, but also appreciate its practical significance in ensuring quality and innovation across various fields. Now let's get ready to dive into the practical and see how these concepts come to life. On to the practical. Let's start by gathering our materials. Sam, what do we need?
So for this practical, we need various items to measure: a measuring cylinder, a ruler, a mass balance, and finally, a lab book to record our results.
Let's begin with our first item. In this case, we will be using a cube. Begin by measuring the cube on a mass balance, ensuring that the balance is set to grams for consistency and that you record the exact mass accurately. Our readings show the cube weighs 500 grams. Record this in your lab book. Next, we need to measure the volume of the cube. As this is a regular shape, we can use an equation for volume and careful measurement to calculate the cube's volume. Using a ruler, carefully measure the length of one side of the cube. This gives us the width of the cube, and as it is a cube, it also tells us the length and the height. Using this information and the general formula for volume, we can calculate that the volume of the cube is 5 multiplied by 5 multiplied by 5, or 5 cubed, which equals 125 centimeters cubed. Record this carefully in your lab book. Now we will use an irregular object, which requires a slightly different process. In this case, we will be using a small rock or stone. Begin by measuring the rock. Just like with the cube, we can do this fairly easily by using a mass balance to record the mass in grams. In this case, the rock weighs 70 grams. Record this in your lab book. Next, we need to measure the volume of the rock. As this is an irregular object, we cannot apply a general formula for volume. Instead, we will fill a measuring cylinder with water. Ensure to carefully note where the water reaches, in this case, 100 centimeters cubed. Then, carefully lift and drop the small rock into the measuring cylinder, taking care that water does not splash out of the cylinder. As the rock displaces the water, we can measure the new volume of the water to work out the difference, and thus the volume of the rock. In this case, the rock has a volume of 35 centimeter cubed. Note this in your lab book. We now have the mass and volume of our objects recorded in our lab books. We can thus use the formula density equals mass divided by volume to find the density. For our cube, the mass is 500 grams, and the volume is 125 centimeters cubed. Therefore, when dividing one by the other, we can see that density equals 4 grams per centimeters cubed. This is 4,000 kilograms per meter cubed. For our irregular object, if its mass measured 70 grams using the balance, then the density equals 70 grams divided by 35 centimeters cubed, which equals 2 grams per centimeters cubed. This is 2,000 kilograms per meter cubed. You can now repeat this process with various objects, ensuring to carefully record the mass and volume in order to calculate the density. In today's practical, we successfully applied our understanding of density by measuring the mass and volume of both regular and irregular objects. By carefully following the steps, we calculated the densities of various materials and gained first-hand experience of how particle arrangement affects density. Through this hands-on approach, we saw how the concepts of mass, volume, and density interrelate through a useful equation. Beyond the classroom, we learned that density is a crucial property in fields such as material identification, quality control, and engineering, where it helps ensure product integrity and plays a vital role in designing buoyant systems. By repeating measurements for accuracy, we reinforce the importance of precision in scientific investigations.